Hi, geometry students. We are looking at lesson 2, day 2. So we're still caring about radicals and square roots and looking for pairs to make perfect squares. But now we're going to kind of build on that, and we are going to be simplifying an expression that has multiplication in it. So you should have your workbook out. You should be on page 5. Now remember, this workbook only has notes, so don't ever go looking for it for assignments. Unfortunately, it only has your notes. But we are on page 5 in that workbook. Now, in the interest of trying to not overwhelm you, not do so much, because I realized I definitely made those other lesson notes too long, too overwhelming, too everything. So we're going to pare this down. I'm not going to do 1 through 4. We're going to jump into number 5. Now, we had practiced simplifying radicals already. That's what the other videos were for. That's what you did a warm-up on today. But now we're still going to simplify. So if you look at I made a little instruction thing here. This is our 2 main steps. So when you see a problem like this that has multiplication, your first step is to multiply. Then your second step is to simplify. This is what you had been practicing already. So we're just adding a step beforehand. So when you look at number 5, 3 root 2 times 4 root 6, this should put in your mind something like in your algebra days, 3x times 4, let's say y. Because the 3 and the 4 here are coefficients. They're things in front. So just like in a problem like this, you would multiply those coefficients. We're going to do the same thing on this problem. So I'm going to rewrite. I'm just going to rearrange it here. I'm going to multiply my coefficients. And I'm going to do the same thing for the things in the radicals. I'm going to multiply my 2 and my 6. Now, you don't have to write this step, but I wanted to explain where I'm getting 12 root 12. I multiplied the numbers outside. I'm multiplying the numbers inside. So I have this new radical expression. It's a lot more condensed. It looks better. But yes, I've multiplied. I have not checked to see if I'm simplified. So that's what I'm going to do. Just like what we did in the other day, I'm going to look for perfect squares. So I'm going to break apart my 12. So I know that 4 times 3 is 12. 4 is not a prime number. It can be broken further down into 2 and 2. But 2, 2, and 3 don't divide into anything other than itself and 1. So I'm going to stop here. So I'm going to rearrange this. The number out front stays out front. The number inside, the 12, has been broken apart. It's a bunch of 2's and a 3 now. Pairs make perfect squares. So since I have 2 times 2, since I have a 4 under the radical, I knew the square root of 4 is a regular 2. So not in a radical, but a regular 2. There's already a regular 12 there, though. And since this whole problem has been multiplication, there's still a multiplication here. And I can't forget about this 3. It didn't pair up with anybody, so it's still hanging out. So if I put it back together by multiplying my numbers out front, I get that my simplified answer is 24 square root 3. So number 6 is really similar. We are going to first multiply, and then we're going to simplify. So I'm going to multiply the coefficients. I'm going to multiply the things out front. So in this first radical, there's a negative 3 out front. In the second radical, there's nothing out front. But don't forget, just like if we had a variable, if I ever wanted to know what number's out front here, there is one of those x's. So how many root 8's do I have? I have 1 root 8. So I'm going to take negative 3 times 1. And I'm also going to multiply the numbers in the radical, which would be the 5 and the 8. So when I put it together, I have a negative 3 out front, square root 40 inside. So we've multiplied. Now I need to simplify. I'm going to ask myself, how can I break apart 40? There are lots of ways you could break apart 40. I'm going to choose 5 times 8 because that's how I created the 40. So I know 5 and 8 make 40. This is a prime number. It doesn't break down any further, but 4 does. So I'm going to keep working it down until the only numbers that divide in are 1, which means I can rewrite negative 3 square root 40 as negative 3 square root. There's 1, 2, 3 2's, and a 5. Pairs make perfect squares. So remember, 2 times 2 is 4, so I have the square root of 4. The square root of 4 is just regular 2. There's already a regular 3 out front, so we're going to multiply those two guys together. And inside the radical are anything that didn't pair up. You can't come out of a square root unless you have 2 of that number. So when I multiply back together, I get negative 6 in front and 10 inside. So negative 6 square root 10 is our answer. So multiply, simplify. Those are your steps. I do want to point out number 7. It's really similar to what we just did, but the ending is slightly different. So I do want to highlight that. I'm going to multiply the outside numbers. I'm going to multiply the inside numbers, which in this problem gives me positive 6. 2 negatives multiply to be a positive. Square root 15. So when I break it apart, well, I know 5 and 3 gives me 15, but in this problem, that's as far as it breaks apart. Those are prime numbers. So if I wanted to rewrite this, it would just be a 5 times a 3. There are no pairs in there. There are no perfect squares. So nothing comes outside to join that 6. I was already simplified at 6 square root 15. So yes, the directions are to multiply and simplify. Some radicals are already as simplified as they're going to get. Now number 8, again similar, but the result's going to be a little different. So let's multiply first. Numbers out front, numbers inside. That's going to give me 4 square root 100. Whoa. 100, there we go. So I've multiplied. Now I'm going to check to see if I simplify. Well, 10 times 10 gave me 100, which means I've got a pair of 2 and 5, 2 and 5. So pairs make perfect squares. So when I rewrite that, that's what I'm going to be looking for. So there was a 2 and another 2, a 5 and another 5. So I've got 2 pairs here. So that's a perfect square. The square root of 4 is 2. The square root of 25 is 5. So joining the 4 is a 2 and a 5. There's nothing left over to be inside this radical. So when I multiply these numbers back together, there just isn't a radical anymore. Now I will point out, some of you might have been just like internally screaming while I was doing that process because you realized you know the square root of 100. This is one that I could have asked you last week, and if I would have said, what's the square root of 100? A lot of you would have realized I just meant 10. And if the square root of 100 is already just 10, and you have a 4 out front, you can just take 4 times 10 and still get our 40 answer. So sometimes your radicals won't simplify at all. Sometimes they'll simplify so far that there's no radical at all. The other thing about this problem I want to draw attention to is I took 2 square root 10 times 2 square root 10 times itself. In math, when we say something is being multiplied by itself, we say that number is being squared, which is what 9 and 10 are going over. I'm squaring that radical. So I'm going to take the time to write it twice. 9 root 5 times 9 root 5. So we're going to multiply and simplify. I'm going to multiply 9 times 9. I'm going to multiply square root 5 times square root 5, which means I'm going to have 81 square root 25. You could break it apart, but again, some of you might already realize the square root of 25 is just a regular 5. So I have 2 regular numbers. They can be multiplied back together. I might also point out to you that 81 square root 25 is what you get when you do 9 squared is 81. Root 5 squared is root 25. So it's not a coincidence that that happened. It's also not a coincidence that when I squared this radical, I got an answer with no radical in it. When I squared that radical, I got an answer with no radical in it. That's going to happen every time you square a radical, because squaring and square roots are opposites. They're inverses of each other. They will always cancel each other out. So the last one we're going to do is number 10. I'm squaring this, so I'm going to take the time to write it twice with a multiplication sign. And I'm going to multiply, simplify. Negative 6 times negative 6. Square root of 7 times square root of 7. So negative times the negative is positive. 7 times 7 is 49. But I clearly had a pair of 7s there. Pairs make perfect squares, so I don't have any square roots anymore. The square root of 49 is the number 7. So I just have remaining 36 times 7, which, thanks to my calculator, tells me is 256. 52. There's no radical because the squaring canceled it. So that's what we're practicing. So make sure you have those notes filled out so you can upload them to show that you did it. Upload it under Unit 1 under Google Classroom. I'll have an assignment there for you to take this picture and multiply